Hi, everyone. Welcome to the 49th FESIG meeting. It's ever so wonderful to get together again. Today's meeting, the 49th FESIG meeting, I refrain from saying which day, Wednesday, Thursday, because we are an international group and spread all over the world. Oh, well, you know, it's 9 p.m. PST time, which is in the US, which the majority of you here who are present today, which is good. That's why we had to choose that time. Whereas it's, and then it's the 7th of February where you are, PST time, whereas it's 8th of February where I am and where Elizabeth is. So there's a little bit of a confusion, and the time is a little strange as well. Where James is 12 midnight, and Eliza is about 6 a.m. in the morning. So we got to move quite quickly now, and I would be okay. I'll start right away with my PowerPoint presentation, and I would start the screen share. Right. Hang on a minute. So here you are. Welcome to FESIG. FESIG is the Free Energy Special Interest Group. Like every other meeting, I have to introduce FESIG very quickly. The Free Energy Special Interest Group is a platform where science and spirituality meets, because we are exploring enthusiasts, scientists, developers, and just seekers of free energy. And alternative energy together here, talking about how we can improve and how we can develop and go further with what we are developing. Apart from, as it's a science meets spirituality platform, we have people coming in as well to tell us some disclosure stuff, some information, so that we can make good decisions to move forward. Right. So that, as I was saying, FESIG, that is just in a nutshell what FESIG is. And so it is a gathering of like-minded people who have a divine mission to move forward. And recently we've been recognized and spotted by Martin Berger of the Blue Energy Incorporated entity. And he's coming up with the cryptocurrency, a new cryptocurrency called the energy coin, which is going to move us forward very quickly, because it's chosen us to airdrop the cryptocurrency so that we can get going with things that we have to do. So today's meeting, as I said, is the 49th meeting, and it's me, Crystal Gore, who's the founder initiator of FESIG, that is putting this together, chairing it. We're co-chaired by the first speaker, Andrew Murray, will be co-chaired by Dr. Elizabeth Donovan. And thank you, Elizabeth, for inviting Andrew Murray to be our speaker today. And thank you for getting him ready for this presentation. And thank you, Fres. You're always there helping me out with putting these meetings together in a very impactful way. And James, you will be co-chairing Anthony Zender's talk. Unfortunately, Anthony Zender has to run off on an emergency urgent call. So the committee, will be catching up with him the next couple of days to pin him down on the talk. And we'll be doing a recording then. So he won't be in this meeting. So this meeting will be quite a short meeting with just one speaker. So we're focusing all eyes on you, Andrew Murray. But let me introduce you first before you grab the microphone. So, well, if you go to our website, the FESIG website, you see what we are all about in more detail. Well, you know, we call ourselves futurist freedom seekers, because that's what we're doing. We are seekers. We've been seeking most of our lives for solutions. As we all know, that something's really quite wrong here on this planet. So here is our meeting agenda, and I've done the quick presentation of FESIG. I have to new viewers, rather, instead of new members. And Joe, thank you for joining us today in today's meeting. And we've got more people joining us as well. And welcome. And thanks for taking time off to join us in this meeting live. So as I've said, I think I've done all items 5. And then once we finish, we will then adjourn to the next meeting, which will be our 50th FESIG meeting on the 7th of March, and also the same time, 9 p.m. PST, because majority of you are from the West Coast of the US. And then after this 50th FESIG meeting, we'll go back to the normal 7:30 p.m. GMT European time, London time after that. All right. truevisionofpeace.com now to our physics site. This is
Crystal, could you check your microphone? Yeah, it's really noisy.
Yeah.
okay. Is it still noisy?
Yeah, it's really scratchy. You might want to check where it's plugging in. It sounds like it's got a problem there.
Okay. Is it still scratchy?
No, it's better now.
Okay, good. Thank you. I was just adjusting the plug. Okay, so this is our website. Okay, if you go to our website, you'll be able to catch up with everything that we have been doing in FESIG, practically everything. And you can read about the Physics New Year gift, 2018 gift from Martin Berger. He gets to play Santa Claus. So he chose FESIG to airdrop to FESIG's world members his cryptocurrency coin that's worth $500 to begin with, and then of course, it will skyrocket in due time after he's done the ICO, the initial coin offering on the board. So if you go to FESIG's website, it's truevisionofpeace.com/physics.html, you'll be able to click on those links. And Elizabeth and I had come up with the idea that we could call our special breakaway community the foundation. And if you click on the foundation, you will read what Elizabeth has written about it. And then if you click on the finder, because that's what you're going to be. If you want to join the foundation, you become the finder. And then you click on this link, you apply within, you just fill in the form, and then we will process it, and you get the gift from Martin Berger. And I think he's going to give more than that. And even if you feel that you're not qualifying by being the condition is such that you have to be doing this work for humanity, like a life's mission, 10 years or more, he says. It doesn't matter. You just apply within, and if there's not too many people, probably, we'll be more lenient with the bar in the requirements for qualification. And there you are. So just fill in here and you will get it processed. Okay, so this is it. And then if you scroll down the site, you see here the speakers are being mentioned here with their bios and links as well. And then if you scroll down, you'll be able to see the last meeting reports. Scroll down again, you'll be able to see the FESIG videos. Of course, the meetings are recorded, and then we have it to process into YouTube. So you get to see and listen on what's going on. Okay, so if you click on this one, you get to see what Martin Berger was talking about. He had been so wonderful, and you can actually get to listen to his speech here in this YouTube when he was doing his presentation in the meeting, and so on and so forth. There's so many wonderful, very special people. Yeah, so I'm going to stop sharing now, so you know what to do with the site. Okay. So here we are. We're back now. So I'm going to introduce Andrew Murray. Andrew Theodore Murray is an inventor, researcher, nature, and alternative energy. Since young, he realized that the physical vacuum is the primary energy source of all observable phenomena and could be coupled to as a means for electrical power usage. So he's really spot on with what we're looking for in the free energy search and alternative energy. Studying physics, chemistry, and biology, he performed experiments both in private and public sectors. Andrew presented with a Sustainable Living Roadshow across the United States on advanced solutions to antiquated hydrocarbon consumption and transportation methodologies. He engineers plasma reactors which reduce harmful pollutants and the development of propellantless propulsion systems, space coherence accumulators, the non-weaponization of space. He collaborated with unified field theory pioneers such as Dr. Elizabeth Rauscher, Dr. Stoyan Sarg, John Hutchinson, the late Guy Obolensky, Elizabeth Donovan, our very own, and Nassim Haramein. Andrew contributes in non-herzian wave mechanics, EHD and MHD material science, bio-mimicry water science vacuum oscillations, unified field theories astrophysics, dusty plasma physics, nuclear waste remediation biological, negative entropy cymatics. Andrew serves to merge modern technology practices with culturally holistic and cosmos-themed protocols to help generate self-sustaining prosperity for current and future generations. So, Andrew, would you like to take up the microphone from here for me? Thank you.
Sure. Thank you so much for the introduction. That was spot on. Thank you.
Welcome.
Well, hello. It's great to be a part of the 49th meeting here. Just so much good work has come out of this organization, so it's thank you. Thank you for the opportunity to be here.
You're welcome.
Yes. So I have I've been invited here by Elizabeth Donovan, who an amazing engineer, and we've been going back and forth on various means of producing coefficient performance greater than 1 technologies and the likes of thereof, meaning of specifically looking at neg-entropic systems and how to use both well, what forces we have available, whether it's thermionic, nuclear, electric, magnetic, acoustic, all these different forces we have to create these type of neg-entropic systems. So I'm here to go back and forth in a way with Elizabeth to discuss more of so what is available and well where things are at in my own, I guess, pursuit and my own research in this. And I'd be more than happy to talk about any of the subjects that were listed in the bio you gave. So I can really go on a number of those. And I would like to ask Elizabeth specifically of something that was brought up of a recent investigation of this phenomenon called cold currents. And I was curious, Elizabeth, if you would like to share a little bit about what the latest update of that was. Elizabeth?
And it's called a quantum battery, I believe. It's called a QB demo is the file that's making the rounds. And after speaking with a friend of mine, Karen Elkins, she said that a contact of hers knows the person that made the video, who is an expert in graphene. And she believed that the discs and the insulators were graphene, but he's calling it paper. So okay. I'm just assume that these separators are paper. The battery essentially is a neodymium disc magnet, approximately 8 to 10 millimeters in diameter. Okay. And then after that, there's a copper disc about a seam diameter about 0.2 millimeters thick. Then there's a piece of paper and a disc of zinc about the same thickness, and then another magnet, neodymium magnet, and then it keeps getting sandwiched. Now, the interesting thing is that after he assembles the unit, he then places a voltmeter across it, and it's about 3 volts.
Huh.
He takes an LED and places it across, and now it can't be normal current because a normal current will not pass through the paper insulator. So, but it does. Now, some people are saying, oh, I mean, he's wetting the paper and it's actually a normal battery. But I discount that because what's happening is that if it is a normal battery, the current going through the junction of the LED will burn it out because you have to have a current regulating resistor.
Yeah.
And it'll just pop the junction. And I mean, he just hooks it up to it. It's a white LED that has a bluish cast to it, which is another clue. Anything that runs on cold currents
Has that bluish, yeah.
Has that bluish cast to it. So then after that, he takes a 25-volt stack of these things and then places one finger on one terminal, and then between 2 fingers holds the same LED, places it on the other terminal, and it lights. Now, yeah, very interesting.
Very interesting. More diamagnetic current potentially, like what magnetodielectric current potentially, less of the actual, less actual current flow as what we perceive as electrons, and potentially. I mean, they still could be electrons, but this could be the cold current, like we're talking about the phonon resonance being excited in the material of the bulk versus the surface. And if we're activating that phonon resonance properly, these phenomena have been reported, and these phenomena could be exerted further to actually cause things that are not superconductive to become superconductive-like, and even further. So that's really interesting that you can do just with the touch of the finger. Wow. That's
right.
That's impressive.
And the other thing is that he said that he didn't even feel a tickle from the battery. Okay, well, at 25 volts, you're going to feel something. So
yeah, there's enough current. Yeah.
Yeah.
Well, I mean,
So,
I think this could be similar though to like Tesla's, or I forgot. Tesla called it the hairpin experiment, but there was Lecher wire, I think is what the original one was called. Lecher wire, where you can do a similar thing of produce a type of phenomena where you can basically tap into where there is zero potential or zero current flowing, but there's zero voltage, but there's still current available, and vice versa. And you can take bulbs, submerge them underwater, connected to the right node and antinode placement on these wires, and then you can get a type of pseudo cold current. It's not fully been seen to be it, but it's alluding to the possibility of creating, the requirements, at least the basic fields required to create this. So it'd be interesting if you think that there could be a correlation here of what's occurring there, because
could be, very well could be.
Potentially.
Yeah, and we know that with the cold currents, essentially, well, back in 1903, 1908, they were postulating that the mechanism for current flow inside of a conductor was essentially a phonon wave that the electron surfs on. So it's kind of like a beach ball in the ocean, where the phonon wave is basically just moving it along, which makes sense because the potential moves at the speed of light, or at times faster than light. And the current, I mean, you've got a drift velocity of the current that's in centimeters per second. It's like molasses going through the wire. So you've got these two big discrepancies. So it makes sense to me. Now, the other postulate was that instead of a phonon, you have an antiphonon. Well, an antiphonon will give you time reverse potentials, which now, instead of pushing the electron through the wire, is pulling it. Right. And some of these cold currents, they're noting that it's coming out of the positive terminal and going into the negative.
Going back to Edison days, just proving Edison right, all the way back then. Positive to negative flow. Okay, interesting. Or sorry, not Edison. Benjamin Franklin. who thought, you know, current flowed from positive to negative.
Yeah, the other way. Well, actually,
yeah.
it does in semiconductors.
Yeah,
But
exactly. In certain ways, yeah.
Yeah, but I
Okay,
mean,
that's interesting though. That's really interesting. Actually, if this is a device that is claiming that, can we access this device, or is it? What's the status of this, Elizabeth?
oh, it's on the web, and it's a 10-minute video that I could probably do a share screen on if anyone's interested, and see if you'd like to take a look at it. It's essentially a guy with a British accent that is doing this whole thing. So I don't know if I've shared this with Crystal or not.
Go
But
ahead, guys. If that is necessary to supplement Andrew's talk today, why not? What do you say, Andrew?
Well, when looking at it, what I'm really intrigued about cold current, I mean, specific for the video, if you post a link, I can review it later, as
sure,
anyone else
no
could.
problem.
Yeah. So maybe we just do that. For myself, with cold current and wireless power and one-wire power, I've done some experiments with plasma physics, specifically atmospheric discharge plasmas that are both non-thermal and quasi-thermal plasmas.
No, those are really interesting.
They are, because the electrons are very thermally hot while the ions are cool, meaning by hot, I mean, I'm normally operating top, like the upper range, and about 16 electron volts is the highest energy I actually have in the electrons I'm accelerating in the type of non-thermal plasma reactions I'm creating. But what I've been able to do, and this goes back actually inspired by by Ed Gray and the Koreas, both Koreas like that, where you have a plasma discharge, which certain plasmas.
Oh, right, the PHEV device. Yeah.
They produce a large electromagnetic spectrum that's considered noise, because it is. However, they also produce a large electrostatic phenomena as well, force. That force is more pronounced in certain plasmas than others. But what I was able to do was, by wrapping electromagnetic coils around a spark gap, essentially, I'm simplifying it, but this is the simplest sense, that I was able to pick up both the electrostatic and electromagnetic field of the plasma discharge and run that through a single wire, which then would go to a load, whether they're LEDs or some low power bulbs, because all these experiments were done below 25 watts, you know, most of the time around 12 to 15 watts, low power. We're talking voltages here, about 20 to 25 kV peak to peak AC, operating around 7 to 15 kilohertz. And at that rate, being able to adjust the spark gap as need be. But at those rates, I was able to achieve one-wire power that you could then touch the outputs and not get a shock. And I found it very peculiar in the sense that the emanations coming from a plasma discharge are some of the most natural, what I mean by natural, some of the most intrinsic displacements of space really available. It kind of, you know, energy is being dumped into space for a period of time, and that energy has to go somewhere. And
it's kind of like a reactive circuit where it's going in and out,
Exactly. It's very reactive, and it has plasma, well, specifically certain type of plasmas can be very dynamically coupled to the environment. What I mean by that is both capacitively and inductively and resistively, depending on the type of plasma, can be coupled many folds more than other components. And this is what makes plasma a very interesting phase of matter to work with, because if you properly create a plasma in the right container, you can use it as an actual pump or an antenna, is what I've liked to been, is what all these theories basically go back to, are these type of plasma antenna theories, where if you put energy into a gas, heat it up enough, you ionize it, you can now put it inside various closed and open field containments, whether it's electrostatic, electromagnetic, acoustic, thermionic, you know, all these different fields. You can then inject energy into the plasma for a certain period of the phase and time of that whatever you're using, a DC or an AC voltage to create that plasma. And you can actually have the plasma act as a kind of a pump system, a type of diode or slight rectification, where you can pump energy into the plasma when the field lines are, let's say, open, so they're coupling to the environment. And then you can then change it, so now it's a closed loop system in the plasma, and then that energy gets absorbed or re-emitted. So over a period of time, you can absorb more energy from the environment than what you're emitting out, or vice versa, which most of the time, of course, with regular entropy, there's always a loss, or the coefficient of performance is lower than 1. But if you do it properly and you act as a type of charge pump, the plasma itself turns into an antennae that can absorb more energy from the environment than it currently has in its closed loop system of, let's say, the 20 watts you're using to ionize it. And then that extra energy that you're coupling to can now be used if you have the proper timing. And that timing gets a little complex, where most of the time, like other people have shown, you have to be in the below 5, even below 10 or 5 nanosecond fall rise time to be able to capture the quickness of the electrons which are flowing in that type of scale for plasmas.
The relaxation time.
Yeah, it's really quick. But with our modern circuits now, and even or more clever means of creating new or creating components, passive components that integrate all the components, the capacitor, resistor, inductor, into one component, which is what I've been having a lot of enjoyment putting together. You can then capture a lot of information and energy, because they are different, right? Information does not require energy. This is the principles of quantum theory, is that information can travel instantaneously, and that doesn't require energy. So anywho, that has led me to researching cold currents, or was one of the things I pursued out of it, and that's why I have so much interest. And whenever I hear other people developing such a thing of getting one wire power, or being able to have a load that both leads are short-circuited together, but the actual load still works. These are all implications that there is something more going on here than just normal transverse or direct current flow, that there's actually this this phonon resonance, or as you're saying, antiphonon resonance, which is more of a longitudinal component in the dielectric force, in the dielectric field. And that has been, I mean, just for people listening in, this has been a primary thing that Elizabeth and I have been talking about, and we started rapping back and forth on, is how important it is to understand electric fields and electrets, and the necessity of how we are missing a component that should be readily available, where we have permanent magnets that we can readily buy. And now we need to have the other half of that, which are permanent electrets. And if we have those two fields, those two permanent polarizations of a magnetic field and electric field, we will be that much closer to really having a device that can last, for let's say 50 years, or really magnets, decrease roughly 10% of the magnetic Gauss every 75 to 100 years if they're just out in space. We could have a device that can last a period of a human lifetime while producing power, meaningful power, and then just needing to replace the magnets and the electrons. So these are all things of interest, and that's why I'm really interested in learning more about what you presented here, Elizabeth, of this, or you are referencing.
Sure. And essentially what it is it's what I believe is it's a cold current battery, or not really a battery, more like an electret that's working in a cold current mode, and it's polarized by the magnetic field. So yeah.
Very much so. Exactly. So getting these, like as we talked about before, getting the E field and the B field, or more or less making sure that the electric and magnetic field are in the same plane.
Right.
Similar to like Birkeland currents, like we see in the aurora borealis and magnetospheric, ionospheric coupling on our planets. Those are the areas where we have this huge amount of energy exchange that we see in nature. And I believe that is a clear path forward of how we need to be engineering these devices. Of course, you know, studying nature first and always building off nature. And that has led to more and more of the conclusions of how important it is to really understand of what a differential, or what are the different type of differentials. And this is something that I know Elizabeth and I have talked about, and I'll bring it up here because I just find it's one of the most interesting phenomena to observe, which is when you have a high enough potential voltage or a high enough potential difference between the same polarity, very interesting displacements occur in a load, whether it's a plasma discharge or a resistor or what have you. What I mean by that is, and I believe this directly applies to looking at cold current and looking at ways of what the electron and what is actually carrying the charge in this case. And what do I mean by that is, here's the example, and this is the experiments that I've done and I've had some interesting results, which have been, if you take, let's say, a high voltage source, we'll start off simple, a voltage supply. Let's say you have 1,000 volts positive DC on one end, and you have 500 volts positive DC on the other end. Now they're both positive voltage, so meaning that there are less electrons there relative to the other side. So relative to them, you can say there's a 500 volt difference, or you can say, one is you have just a 500 volt difference. But because they are the same polarity, if you put these in a certain, let's say in a plasma discharge, for instance, the electrostatic fields are in repulsion mode. So the field lines are not trying to stay in a closed container. They're actually coupling out into space and trying to loop back on themselves. And they are going on a much longer path outward rather than being, if it was a positive negative, or at least something going to ground. And what I've found is that the electromagnetic fields produced by these type of discharges that are between the same polarity but different potential, those create a much larger ratio of longitudinal fields than actual transverse electromagnetic fields. And that has been very interesting for me to explore this in seeing that you can kind of defy what you would expect to occur by simply taking a high voltage transformer, taking one lead of it and splitting it in two. So if you have the same exact voltage on going to two electrode system, you can still get a discharge or a differential due to the leaking capacitance to the environment, which is like 2 picofarads of capacitive coupling to most things going to earth ground, roughly 2 to 5, somewhere on there, depending on, just a stray capacitive coupling. So these modes, I believe, directly resemble phenomena we see in space a lot of the time with magnetic reconnection zones and the X1 and the X2 zones, where there are these phenomena which we can't explain most of the time in mainstream understanding of what's occurring with a potential difference. Always saying, positive, negative, or positive to ground, which is considered negative, or negative to ground, these things like this. Whereas if we look at it from setting up fields where the electric field or the magnetic field or what have you is in a repulsive mode, but they're still differential enough that there is a asymmetry, that there is a biasing towards one way and then oscillating between that, just like a biased RF circuit where you have 100 volt bias and RF's AC, or an RF signal riding on top of that. With the right combination of those, there can be a certain displacement of the charge carriers in that zone that seems to allow for phonon resonance to be created. And that's what I'm really intrigued at studying more, specifically related to also knowing other people like Dr. Elizabeth A. Rauscher have shown that you can induce phonon resonant frequency by doing a type of trickle discharge or a trickle high voltage DC discharge, and inducing phonon resonant frequencies to cause thermal energy to be displaced with a very little amount of electrical energy. And what do we mean by that? For an example, the availability to use a 10-watt high voltage DC corona discharge to cool down a glowing red hot piece of aluminum, or a titanium, sorry, to go from 850 degrees centigrade, or sorry, 950 degrees centigrade down to 700 degrees centigrade in a period of 2 minutes. So that's a lot of thermal energy to dissipate with only 10 watts of electrical input. And these are the type of phenomena that phonon resonance occurs when you have the phonon resonant frequency of the air, for instance, to match that of the titanium. You can actually get the thermal energy to flow in directions that would be counterintuitive, such as cooling the plate off. Yeah.
Yeah, I've actually seen some demos of something similar to that, where there was an electrode on the other side of a piece of paper, and they would actually place a flame in the paper, and the paper would not catch fire because it would never rise to its kindling point. So,
it's amazing.
Yeah.
See that?
Oh, yeah.
These are the type of technologies that are available when you match that. And to match the phonon resonant frequencies of most materials, like say on the periodic table of elements, most phonon resonant frequencies, like the subharmonic of them, because there are different harmonics of this, but you can reach the phonon resonant frequencies of most of the periodic table of elements between 1 to 80 megahertz. That's the range that that it's been calculated to actually, like, let's say I can pull up my chart here, depending on the density of the material, that determines its phonon resonant frequency. The denser it is, the higher the frequency, because acoustics travel much quicker through dense materials than rarefied materials. And that's showing, once again, these phonon resonant frequencies, or phonons, these quasi-particles, obey or conduct in a type of longitudinal fashion. And that is one of those fundamental things that is still being probed as into, well, if information, as we know, sound waves can't travel through space. That's clearly understood. You can have sound waves trapped in an ionized gas, though, like a nebula that's traveling through space. So sound waves travel in that manner. But the actual manner in which the vacuum is actually a plenum of energy, which we are coupling to, that mode, that coupling expression, you might say, going down to the Planck scale, that seems to obey a much more of a, or we're missing more or less this longitudinal component of what these phonon resonant phenomena, such as cold current, are alluding to. And believe that we can continue to achieve that by looking at how to take an open and closed loop system and, to couple those more efficiently by switching at the right time, where you have a certain amount of energy around you, which, we have all this energy around us, and bring that into your closed loop system. So that's the
and showed that was around 10 to the 93rd or 94th ergs per cubic centimeter, which is an enormous number.
That's a lot of energy. That's right.
A lot of energy. Oh, yeah.
Right. So yeah, developing the right resonant cavity chambers, as you know, Elizabeth, is still of high interest. Looking at all these phi ratios and Fibonacci. There's all these beautiful ratios out there. And also, we have all these constants in physics, fine structure constant, the alpha constant, Euler, all these constants. They all mean something, such as the free impedance of space, or of air at least, being 377 ohms, 377 point something. That implies a lot there of why this is, and why you can be in the vacuum of space. And it's roughly the same thing. It's really an interesting phenomena there. And I believe that it alludes to, or helps point to, one of the requirements of tuning let's say if we wanted to tune a Tesla coil or anything to the environment, if you tune your system to the free impedance of space, that means you're going to be able to basically have a quote-unquote short circuit between your coil and space, which is connected to everything. Because it's
exactly.
And then by switching it between being connected to everything and then doing the inverse of that, which is basically a dead short circuit, if you were just to do the inverse of, 1/377, for instance, there's a theory that could be a ratio of how to couple from space all this energy into an open field to a closed loop system, for instance. So yeah, these are all things that nature does readily, as we see, like for instance with the sun. The sun, for instance, goes from a dipole to a quasi-pole. That 11 or 13 year cycle like this, and cycling, to me, it implies heavily of a charging mechanism where most of the time it is a dipole which is emanating a lot of energy, and then every so often it goes into a quasi-pole moment where it looks like it's a coupling constant where it's actually recharging in a way. And what I've been observing, the field lines are being disturbed in such a way that there's this coupling between the closed loop to the open loops, open system of the larger than our outside of our heliopause, for instance, and then it goes back to a dipole, and then of course the magnetic field's flipped, which would make sense once again for either taking energy in or out of a system. Whenever whatever dipole is flipping and it's in that blotch wall neutral or just null zone, it's the easiest way to move something around, to say the lowest amount of energy exerted to displace or lead energy to go one way or the other. So these are all things that I find are extremely important, and it shows us how to build electromagnetic coils, how to build basically devices that resemble how to get these fields as well as these potentials, the scalar, single dimension quantities, temperature being a scalar, pressure being a scalar, things like this. And how to re-look at Maxwell's original 60 equations, which 4 of them are the common ones, which are known and are very complex. But the other ones that have just more or less been omitted by Heaviside because they were just dealing with that scalar vector potential, just looking at just the scalar potential, just that alone. That's where a lot of the quantum phenomena are observed. And it's a kind of an exciting time nowadays where people like myself and I know that you, Elizabeth, are probing into this more and more of, okay, we need to re-look at, Amperian current, when Ampere was showing, longitudinal currents versus Grassmann's theories versus just seeing how honestly simple it is to set up these experiments that show that show a different expression of the energy or the movement of charge carriers than what we are all common with, with AC transmission lines and the latter.
Exactly. Yeah. And it's interesting that a lot of the researchers are finally coming to grips with the original Maxwellian equation set. In fact, I talked to one just a few months ago at the University of Madrid, and he lamented the fact that he couldn't teach it, but he could experiment with it.
That is it's such an interesting one, is it not? That the inability to teach then requires the pursuit of experimentation and empirical results. I very much like this Chinese proverb that says, "Those who know but do not do not know." And I find that I try to hold myself to that as much as possible, where there's so much information and knowledge to obtain. Without compassion, though, for oneself and for others, nothing gets done, though, without that, compassion.
Absolutely. Here.
Heavy leader for it. Yeah.
I'm so with you on that one. That's why in FESIG we are urging people to walk the talk, do the work.
Yes, exactly, doing the work. And on that, there's some really simple ones to show how work can be done. For instance, like for electrolytes, for instance, and this phenomena of electrolytes. It's a really simple experiment to do, but next time it hails, go outside, pick up a couple pieces of hail, let's say 10 pieces of hail, and if you have some aluminum foil, build a little capacitor, put the hail in between two pieces of aluminum foil, and measure a DC, and measure, put a voltmeter on it, and you'll get a small DC voltage out of it, due to the fact that as the water froze, it was in the atmosphere where there is a large voltage potential, right? The ionosphere has anywhere between 250 to 400,000 volts positive DC around it. And of course, there's various layers and had dark side, night side, but there's this large voltage potential. And while the water freezes in a cloud, the dipoles can get aligned to that electric field and hold that charge. And while there's hail is falling to the earth, it's carrying a current with it. So that phenomena is another telltale sign of how we can use that phenomena and more or less create what I call a phase transition battery, more or less. It's not truly a battery, but it's a closest approximation I can get to it.
Yeah, like a quasi-battery, yeah.
Yeah, exactly. In such a way that we are actually tapping into the moment where you have a phase transition between, a solid to a liquid to a gas to a plasma. Whenever those occur, there's, of course, a loss of energy most of the time. However, in the proper environments, such as if water evaporates to a gas, you should be able to change the amount of energy required to do so if the proper fields are applied at the moment of phase transition. And there's a lot of research finally being done on this, with our modern technology of being able to see the actual transition of water going from a liquid to a gas. I'm blanking on the gentleman's name. Wonderful, one of the world-renowned water physicists who's over in Washington, I believe. But he was able to take pictures of this and actually was able to observe a negotropic effect, it seems, where at the very point of a droplet of water evaporating from a liquid to a gas, it forms a geometric crystalline spire that looks like a crystal. And of course, crystals are, very, very structured, and there's a lot of energy available there. But it's interesting to note that going from a liquid to a gas, things get more chaotic. So there's, entropy increases. However, at that moment, when there's a phase transition, there seemed to be a negentropic effect where the liquid water turned into a quasi ice crystal, which would go the opposite way and then release that energy into a vapor. So these are another one of those phenomena I'd like to I probe into, of saying, well, can we tap into that by applying the proper fields around that to actually, couple to a phase transition to start to, eventually to create a chemical closed system, which electromagnetic, where the fields couple to an open system, so that you have a chemically closed, chemically closed system that couples openly to the fields around it. Another point of interest of how to do this phenomena of producing, as even with this organization here called Free Energy, which of course it is a good way to get the information out there. Free energy. This is free. It's financially free. Whereas as I've found, it's very interesting for me to see that with all this work that has been done, we still don't have devices I can just go buy off the shelf, and there's still a large pushback in people saying that this is not possible to create something that can run for 100 years without needing to be recharged, even though we observe it in nature all the time. So I'm very interested and dedicated to this, and I'm happy to know that there are other people like yourselves who are dedicated to this process. And so I want to take a moment to thank everybody here for their work and for being interested. in this possibility.
Oh,
It's beautiful.
thank you. Thank you, Andrew.
Yeah.
Well, Elizabeth, you want to wrap it up and get the Q&A going?
Well, sure. And let's see if there's anyone that has any questions, just go ahead and pipe up, and let's get a discussion going with that.
One more thing, actually, possibly just
Sure.
just to notice, because that's kind of, I'm feeling like kind of like a recap, honestly, between just some of the stuff you and Elizabeth, you and I have been talking about.
Sure.
There's been some more insight of like the importance of canceling the E and the B field inside, let's say, a three-dimensional capacitor, or just you know, if you have a closed sphere, a hollow metal sphere, let's say copper sphere that's 3-inch diameter, you can cancel the electric field inside. Now, if you make that a ferromagnetic,
Tesla did that. Yeah,
exactly. Yeah. So now, if you create a ferromagnetic sphere, you can start to cancel the magnetic field, because now, or at least you can divert the magnetic field around it. So if you do that properly, if you create enough layers, so let's say you just put a ferromagnetic hollow sphere that's 3 inches, and then you, inside of that, you put a layer of insulation, a dielectric, for instance, let's say Kapton or Teflon, just for fun, or you know, anything of this nature. Anywho, you can then put another layer of ferromagnetic material, another sphere inside, and you just keep building layers, basically a type of Faraday cage. Eventually, you will be able to divert enough the electromagnetic field, where inside that hollow zone, inside a cavity, there will be a null zone, where basically the Earth's influence of electromagnetic fields are more or less zero. This is interesting, also goes into philosophy of, if you create a vacuum, nature fills it. It's just something nature does. And this is no different, meaning that...
and we can get into the Casimir effect after that, too.
Yes, we can. And this is what gets fun like that, of showing that this is something that Maxwell actually was very intrigued by, was that, looking at gravity and time dilation, he was alluding to and referencing that the charging of a capacitor actually has this strange phenomena of a slight time dilation, of the ratio of entropy to negentropy slightly shifts when capacitors are being charged. And this has been shown also now to be used with using high permittivity or dielectric constant materials. You can start to, it seems, detect more subtle energies, gravity waves, and even intent, oddly enough, if certain people have claimed, and I've researched, and I'm going to be building some of these. It's quite interesting. But just bringing it back to the point of, if you have a three-dimensional multi-layer Faraday cage, more or less, that's ungrounded, more or less, you can actually, let's say you apply a voltage to the outermost layer, let's say a DC voltage, even though the electric field is canceled inside of the layers, the voltage will still be induced upon the inner layers due to the electrostatic induction, that first beginning mode. And depending on how it's configured, you can exemplify that. You can get to the point where, even though the electric magnetic fields are canceled, there's still a voltage gradient inside these layers. And why that's really interesting is, well, if you have the electric field and magnetic field canceled, but there's still the movement of current, which through the proper induction mechanism, not just that you do direct DC constant, but pulsed is much better. So it's actually pulse, or any change in current passes through a capacitor. DC blocks it, obviously. You can get to the point where that the inner chamber itself is not only canceling all the external fields, but whatever is inside that chamber can actually be amplified in that simplest sense, meaning that whatever space or whatever object is in there, it is now being immersed in a field that has no electric or magnetic field. It is purely as Maxwell was saying, whenever there is that mode where you cancel both out, but you still have current moving, you have to be interfering or interacting with time. And if you're interacting with time, you're inversely, you're dealing with gravity as well. And it is a really straightforward experiment and simple setups that have huge implications and actually can be quite dangerous, as Wilhelm Reich found out when he put radioactive materials inside some of these devices and changed the radioactive half-life decay of them. And even though he caused the material to actually chemically change, which is fantastic, it rewrites nuclear physics, it got everybody he was working with, his researchers, his
they
team,
all became ill.
They all became ill. Not only ill, but they also had psychotic episodes. It was a big deal. And it is my opinion that these things need to be re-looked at into building simple construction or simple devices where you cancel the E and you cancel electromagnetic fields, as many fields as possible, while still allowing certain inductive modes to occur, such as electrostatic electromagnetic induction, in the proper manners, in such a way that you force, you more or less, it's like a planetary gear set in an automotive and in a car, for instance. You have to have one gear held to allow the other gears to properly work. So you hold the E and the B field while still allowing torque to occur. That torque is going to be the result, or going to be interacting with time and inversely then with gravity. And this has been shown by Guy Obolensky over and over again. This has been shown by, I mean, multiple people, that if you can really create a cavity where there is as little of external influence as possible, then that's where you have to start from a place. More or less what I like to call a type of cosmic womb, I like to call it. Because then from that, you can then more or less, and you can plant a seed which will grow, and more or less, as any COP greater than one device performs, it takes a period of time for the energy to be shuffled back and forth between the closed and open loop system, to where eventually now you're actually having more energy, more work can be done while you've only been trickling in a small amount. So I just wanted to also just mention that there are these straightforward and basic things that can be built, which prove how to couple more effectively to the environment between open and closed loop system when looking at just re-looking at Maxwell's equations, not just the four, but the other the other ones that have been on
set, right.
And it is a lengthy set. And to be frank, I do not understand the majority of the math behind it. The theories and the conclusions, though, are very straightforward. And that's something I just want to say. I'm very appreciative, Elizabeth. You just to give you the proper just thank you for all that you have, all the work that you do, and all the dedication you have to these projects. It really has been amazing getting to interact with you, Elizabeth, over this past year or so. It's been amazing, man. So yeah, more of this, Elizabeth. Thank you.
You're welcome.
All right.
So yeah. Speaking of cavity resonance, Viktor Grebennikov. That's an interesting one too. So he actually experimented with different insect carapaces and noted that because they were nonlinear dielectrics, they could actually have a nonlinear electric field component on the inside of it. And that's one of the things that he thought was causing the effect.
Yeah, I always pronounce it improperly. Chitin, I think. Is it
chitin?
Chitin? Yeah, chitin, yeah. Very, very interesting claims, right, of how he was able to create this levitation craft with just insect wings, basically, and a type of gearing or a shielding mechanism to control the amount of lift that was coming from that. Very fascinating. Very, very fascinating. But yeah, these are the things we have to look into more, though, of really observing the dielectric and differentials, as I was saying, nonlinear dielectrics, and looking at any asymmetry in a system is really what we're going for, and rocking an asymmetric field in a type of cadence. And this gets into the idea of, I call them wandering monopoles, but there are some basic hardware experiments you can make actually that show the existence of what a monopole actually is, such as a magnetic monopole, such as we observe in spin ice and things like this. You can create a monopole for a very small sliver of time whenever there's, a north-north or south-south field between two magnet, two dipole magnets. And it has to move, obviously, because it's displacement. But if you do it properly, it can be looped and create knots. And this is one of those investigations of looking into nature that I find very intriguing, of how to actually loop wandering magnetic monopoles on themselves in such a way that they create, I'm equating them to chemical resonance, such as in benzene rings and carbon structures, whereas the electron is freely able to change bonds, double bonds, single bonds, with no extra energy input. And I believe that is straight a phenomena of these type of characteristics of these type of wandering monopoles. And I'm investigating that at the moment. Yeah. So I just wanted to just really hone on that, of just how amazing it is that nature shows us the blueprints. And now we know in our 21st century, 2018, we have a lot of very powerful tools to be able to not only listen, but to implement what we are participating in this this reality.
Absolutely.
So,
absolutely.
Yeah, it feels like a good year to, get her done,
Yeah.
All right.
Okay. So does anyone have any questions? Fraz, do you have any questions?
Oh,
I bet you have.
of course, I always have questions.
Okay.
I'm going to go down the list real quick, and because it's going to recap what Andrew has been talking about. You first started talking about the neodymium, copper, zinc, copper, neodymium, with the graphene sheets between the copper and the zinc. And the neodymium magnets have an attractive pull to each other, if I understand this correctly, but they're pulling together. Is the circuit that you're looking at, is that possibility some of a piezoelectric effect?
Evidently not, because if it's a piezoelectric effect, what would happen is that there'd be just a momentary charging of the system, which means that the LED would go on and then go out again. But evidently the LED that he's demonstrating is on continuously.
Okay, excellent. I needed clarification for everybody on that one. The next one coming down, you talked about the foil with the pieces of hail between the two of them. And then you went into the next topic, which was the copper spheres. And ending up with the same thing. But what you're talking about in many ways on the small scale is the same effect, because the hail is accumulation, like all-day sucker or a jawbreaker, and each place that it picks up a ring of ice on the outside of that, it's a different altitude, and these hailstones go up and down in the atmosphere, sometimes thousands and thousands of feet as they accumulate it. So you are, in effect, the two are very similar.
Yes, very similar.
Okay. And so what I'm looking at, just as a thing, when you say, well, we need to have a way of setting up a Faraday cage type of effect, because that's what you're doing with these things. Maybe we're, as experimenters, we're looking at the too small of a scale, because it gets really hard to figure out how in the heck do you get this inside this little jawbreaker structure that's sitting on your desk. Why not go rather large and basically build rooms one inside the other, and have a doorway where you open it up and close it, and then you can get your experimenter inside the field. And it's just a matter of, you may have to pack an oxygen tank with you or something. But as I say, maybe we're dealing with too small, because I all of a sudden I'm sitting there looking at the little bit of work that I've done in this, and I'm sitting there going, yeah, it's really hard to get inside these.
It is. Yeah, it is. And on that, Andrei Puharich did a great job on that in the 80s, doing PK work with Dr. Herok, Hertog.
J.T. Hertog,
yeah,
he also worked with Uri Geller on that too.
Yeah, amazing work. And what they found out is that they built a 2-layer Faraday cage, and they applied a Van de Graaff generator to the outermost layer that was ungrounded. And they claimed that they were able to increase their PK abilities by 2 to 3 times by applying a high voltage DC to the outside of their ungrounded Faraday cage. Unfortunately, all that documentation was lost when the fire occurred at his facilities, at his house. And the only mention of it was in Dr. Elizabeth A. Rauscher's and the Hertog's book, Mind Dynamics in Space and Time, which came out in 2016. There was only a little mini reference in it. But that is, like you're saying, to be able to have a full room would be fantastic, and it's just a matter of money to do it. I'm going to be building small ones, which I'm doing right now, demonstrating these principles, as well as what you were saying with the clouds. I mean, with the ice, real quick. There's a great thing called the Lord Kelvin water droplet experiment. You know, a very fun one to do. And I had a buddy. It was pretty cool. I want to replicate this on a small scale, like you're saying with room in the room. He built one, a pretty sizable one. He put it in his garage, and he plastered 55-gallon black trash bags everywhere around just to insulate it. He turned it on, and he left it on. He didn't have a spark gap. He just let it run. So it built up a rather large electric field over a period of days. And, of course, you can build these things properly where the water no longer touches the ground. The electric field is so intense that the water droplets just circulate around the top electrodes over and over and over again. Like you were talking about the hail. It just goes over and over. And the thing that he observed, and this is what I want to replicate, was that he came back a few days later, and the whole room was a giant cloud, first of all. You know, just all the water, he just continuously poured into it. He just kept adding new water in, was suspended in clouds. There was some water residue on the bottom, but the majority of it was just cloud. And this is where it gets interesting. The room was glowing. That's what I want to replicate, is the idea of enough of a discharge happening that not only corona, I'm interested if we do it properly, if we can get a stable ball lightning to occur. The answer is very much yes, if the way that the electrodes are configured and the type of water, because you can use, I use the Lord Kelvin water droplet experiment to show the difference between structured water and tap water and things like this. It directly shows the electrostatic potential induced upon the conductors depending on the potential difference of the water you're using. And with that, it's already interesting enough. However, to create a potential power supply, which is like you were mentioning, Fraz, of chemically closed room inside another chemically closed room, basically a 3-dimensional capacitor, we should be able to pull energy out of this quite efficiently if properly built, and then couple it in such a way that the COP should be greater than 1 if we are following what nature shows us how to do, meaning temperature controlled, pressure controlled, and the likes. And some of these, honestly, I can talk about the concepts. Some of it I am pursuing actually and building things. And so, always open to talking about the concepts though, and the basics.
Well,
and if anyone wants to build stuff, let's build it.
With Super Voices, we bring the conversation from beginning to end, and for the other listeners, you talked about the ice and the water evaporation point where it goes from a water droplet to water vapor, and it forms a crystalline possibility or an ice in between.
And spire.
One of the things that we observe and we don't realize it is that we can have that interface between water and vapor at different temperatures.
Well, of course, you have a triple point.
Sure. You end up taking, let's say, your cube of ice in your ice tray, and you put it into your freezer, and over a period of time, the ice diminishes. It goes into vapor.
Sublimates.
And it shrinks. So you have a lot of places to play with this temperature and still have similar things going on with water. Water is a very strange molecule.
Yeah, exactly. And we need to, yes, very much so.
Okay. And if that sparks another idea, that's great. I'll let you riff for a minute.
That's Dr. Gerald Pollack.
Okay.
That was the person I was referencing who did that work of showing water going from a liquid to a vapor, and at the moment where it actually transitions, it forms these little nanospires, and then it drop by drop, it evaporates from those nanospires. Okay, that's all I wanted to mention. Is that was the doctor?
Yeah, it's a really fun property of water. Yeah. And the last one is the wandering electrons, or wandering in the benzene rings. Yes. And there's a similarity to that in the electrical circuits, and it's called a Joule-Ringer circuit.
Very familiar.
We're replicating that same thing of the benzene in an electrical circuit. Mm-hmm. And when we're picking it off, what's happened is we're charging that Joule-Ringer circuit almost like a capacitor, but the electrons are spinning still in it, even though there isn't a charge in it, and then we're bleeding it off in another spot. But we're bleeding off sometimes more than what we're putting in. So.
That's right. Joule-Ringers, or some buck boost converters, or basically Joule-Ringers, or self-blocking oscillating diodes is another technical term for them. Built a few of them. They are quite fascinating. I would highly recommend, if you are doing this work, of looking into adding in shorted coils to your Joule-Ringer, because there's Joule thieves and Joule-Ringers, and I forgot what the other one. They're all slang terms, right? But basically, the experiments that I was doing with those before were showing that if you have your bifilar coil going in, to wind more coils on your core and short them on themselves, going through capacitor, making your own LC basically. And if you have a coil, its own coil shorted on the transformer, you can start to create what's called a, I don't know if you do it properly, a magnetic amplifier, which were, before tube amplifiers. And when you do it properly, that's when I was observing some really interesting phenomena with Joule-Ringers.
So I just want to
fascinating work,
Andrew, that the FESIG members ought to go back to Patrick Kelly's information about what he has compiled in his book, PJK book of free energy devices. So go back there and look up his description with diagrams and all that on the Joule ring and the Joule ringers and the Joule thieves. The difference between the two and the diagrams and everything to relate to what Andrew's talking about. Thank you. Interesting.
Because
it is.
Yeah, in that particular one, right, in the next step on that, you're talking about the short in it. We take a look at the work of Tesla, and he was working with a circuitry that didn't deal with transistors.
Right. Tubes.
We're doing it in a small scale with transistors, but he was working in a large scale, and transistors hadn't been invented yet. Right. But he was the master of the coils, and so what you're talking about is that transition between the transistor type technology and the coil technology when you short out a coil in your Joule thing, and it's just
we have to go back. We have to go back then. We really do, and I'll give you this because it's not proprietary at all. It's something that I enjoy building, and I hope we all build these more often. If you make an electromagnetic coil that is using wide ribbon wire, so it has a very high capacitance, such as Tesla made a bifilar coils for the primary, or a large part of that, so that the self-capacitance was so high that it would actually, would change its resonant frequency to more match the secondary. Because without that, they would just be way too far out of whack to really get, reasonable tuning without having a lot of extra capacitors. So looking at the practicality of what that really means, making these, like you're saying, Joule-Ringers or anything that you want to have a mixture of a inductor and a capacitor basically coupled together, you can do that fairly readily by using wide ribbon wire and winding them in various configurations. And I'll let your imagination go wild on the vast amount of coil configurations you can come up with, just with coils in general. But now envisioning them, let's say, with 3-inch wide ribbon wire, that's a 16th inch thick copper, let's say, you can do some very interesting effects with that
Definitely.
are very difficult to do without it, meaning you can get a lot more of the near field coupling than the far field. And that near field is where these longitudinal dielectric fields are present, as is observed with the Debye sheets in plasma or the likes, or electromagnetic fields in antenna. So yes, I'm very happy to hear, friends, that you're on the jewel ringers and jewel thieves, because that technology.
Well, and then on the other side, when you take a look, when you talk about the wide ribbon capacitors, you're really looking, wide ribbon coils, you're really looking at some of the capacitor formations, the old school capacitors.
Yep.
And how they were built.
Exactly. And it's like, how do you now couple that to not just be a capacitor or just to have an inductor be an inductor, but to really merge the two? Meaning that, once again, as you know, with jewel ringers, getting into multifilar windings, imagine doing that with wide ribbon wires, basically. And you can get some really interesting phenomena when doing that.
Okay, I'm going to back out and let somebody else come in, but I thought I'd basically tie all those points that you brought up tonight all together. So thank you very much.
I'm so glad that you are speaking together like this, because we are actually really looking out for a team where we can actually come up with something, sort of a workshop to help the people out there who are watching our videos. If we could come up with a workshop to come up with a small little homemade free energy device, as what Patrick and the rest of us were trying to get our hands on, it would be cool, Andrew.
Yes, cool, fun, and needed, because this is
wonderful. Yeah, I mean, you seem to have all this practicalities lined up, and the possibility of, I can see more and more possibilities of making these devices and helping people get going to save their electricity bills or energy bills. That would be so helpful. And I have a question here, Andrew. I mean, you were talking about the anti-gravitational aspect of things, and you did mention something about insects. So that really brought me to the thought of Victor Stepanovich Grebennikov with the natural phenomena of anti-gravitation and invisibility in insects. Remember, he was experimenting on that, and he claimed to have invented a levitation platform which operated by attaching dead insect body parts to the underside. And he even had experiences flying over the Russian countryside using his levitation device. So I was thinking, could that be, had people actually really done more research on that, or brought his work forward and developed it to a more applicable stage where, in China, people have already been using levitating scooters, bikes, vehicles and all that. So I don't know what kind of technology is based on that.
It's an interesting one to really mention, because that work is so, it's tough to really fathom, honestly. It's important, like, for instance, in the realm of science, right? It's great to be an open-minded skeptic, right? To be open-minded to hear the ideas, and as well as be skeptical to see, is this actually make sense? The platform you're mentioning, the claims, I'd really love to know that they, to see a replication of it, because, the platform, the pictures that are provided, right, of this small, looked like, like a 4 foot by 4 foot kind of square rectangular platform with a post coming up and handlebars. And he claimed that he would be able to go so fast that time would dilate, and that he had created his own little bubble, basically, where he would go so quickly around the world, he'd come back, that time would be different from the relative time frame that he left and started. So these are some pretty outlandish claims. These are large claims. And one thing I've always been interested with a lot of the stuff from Russia, whether it's torsion fields, which is a fascinating field of study that the Russians have been doing the primary research on, dating back, pre-Cold War era, is, well, what happened to all this Russian research? What happened to all these Russian inventors? Where is this technology? And in the largest sense, this stuff needs to be applied more, like you're saying, to more practical applications.
Yeah.
And I do believe, though, that these technologies, for instance, with anti-gravity systems, you call it like electrogravitics or electrokinetics, developed by T. Townsend Brown, back in the early 50s, more or less, or before, actually. Yeah. These works are very they directly show how to couple to what this this phenomenon of gravity is, because that's what a lot of this is showing that, first of all, as we know with mainstream physics, it's finally being accepted, or at least accepted on certain scales, that gravity is not a fundamental force anymore. Like the 4 fundamental forces, right, of weak and strong nuclear force, gravity, and electromagnetism. Gravity is no longer considered a fundamental. It's a secondary resultant, which is fabulous. It's finally great that that's been accepted. And that leads to showing how, for instance, these electric fields can actually create or displace and couple to gravity in such a way that that is more or less lost when looking at, let's say, the basic 4 Maxwell equations. They all just kind of equal out to 0. But with doing the oddities like you're talking about, it's very clear that there are phenomena that have been observed. To get it out to the people, though, to be frank, they are quite dangerous. If you think about it, if this device is real, let's say, like for instance, the being able to have a podium that you can levitate off and go around the world really quickly for cheap. If there's time dilation occurring on that scale, if someone accidentally fell asleep while this was occurring, who knows what would happen? I mean, they could be lost in a whole other, time era. And so there are these things about our these ideas of why don't we have this technology already? And there are, different modes of thinking about it. One of it's, it's being suppressed. That's always the one that's apparent, or at least, present. Myself going, hearing some interesting things and having, anywho, besides going into all that, the history, there's the other aspect of that this technology is not brought out yet because there's just not proper support. And that's honestly more of the reality of the situation.
Yeah, we've gone through that over and over, Andrew. The suppression thingy that's going on all over the world, we feel like we are so suppressed that we can't even come out with anything. And then they are in a secret space program. They're using such advanced technologies that made us feel so primitive. Well, it's really the suppression, as Eliza puts it, because we could match that already. Did you say, Eliza? Technology stuff there already. It's just been suppressed. So anyway, to wrap this this presentation up, because time has gone on longer than we envisaged, I would like to thank you, Andrew, for coming in to give us such a very interesting insight into how things can work and how things are going to come together. Thank you so much, Eliza, for bringing Andrew to FESIG. And I hope that one day we'll be able to get together physically to work in a lab and come up with things that are going to be so practically useful for all concerned. I think I've got to go around the table because there's there are about 10 of us here, so we could go around the table. Not too many to go round. Has anybody got anything to say before we wrap up this meeting? Oh, okay. Before I wrap up the meeting, I would like to ask, Anthony is still here on his mobile phone, on the go. Anthony, if I were to unmute you, would you be able to speak to me if I'm not interrupting your meeting out there? Would you want to continue speaking as the second speaker in this meeting, or do you want us to schedule another time? The Executive Council members will be with you when you speak as the second video. What say you, Anthony? Can you hear me? Can you speak? Okay, I guess Anthony is engrossed in his urgent meeting right now, so let's go around the table. Okay, Fres, Eliza, and I had our say. What about you, James? James, you got anything that you want to add?
Yeah, hi there. Yeah, I find the Grebennikov, I'm trying to make sure I pronounce his name right, that device fascinating.
Yeah.
Do you think it could be just replicated if we just get a bunch of, because I know he's using beetle wing. Yeah. But he was using like the inside of the beetle wings, like not the covering, but the right underneath it. Is there a way we can just get a bunch of beetle wings or some other kind of insect wings? And
I think James, he came across this discoveries because he was resting on a mound, and underneath the mound was some beehives or something like that. And you know that bees, their home is in catacombs, right? So it's the you know, the quantum physicist was talking about how the catacombs, one is the vacuum, and they're all nested one after the other, and the other one is actually housed, and then next one is vacuum again, and the vacuum again. So working on that basis, I guess the levitation formula has come up, and he managed to levitate. So it's I don't know how to explain it. I'm not a scientist myself.
Well, if it's based on shape power, theory dictates that we could just 3D print it, the catacombs or whatnot.
The catacombs.
Andrew, what do you think?
Well, with the shape, you are right in that way. In a lot of ways, it's been shown that just by changing the shape, let's say of carbon, you know, like carbon nanotubes, for instance, it completely changes its characteristic platform. And this has been shown also for structural integrity too. Nanotechnologists using, you know, nanographic lithography are developing amazing materials just by changing the shapes. Now, for the idea of how to create that effect, you know, using the chitin like that, we're looking into. I remember he was saying it's a specific type of beetle. They're endangered. These type of things like this that are possibly not the best idea to go towards. However, if we can find that, we can probably create a synthetic material out of that, and then
exactly.
Yeah. That would be very interesting. I forgot the exact beetle he claimed, but I do remember him saying that they are a rare type of beetle. But if we do find that, yeah, it'd be great to synthesize and replicate because, yeah, I've personally acquired a lot of chitin throughout my research. You know, from jellyfish carcasses and things like this, and it's just a fascinating thing to study to create those things.
But you know something? What I like best, what I love best, would be the reactivation of our dormant DNA, and we could fly ourselves. We could have our gifts back, our psychic abilities, our clairvoyance, and whatever, everything back. And we could have our own light body Merkaba spaceships.
Very much so. I'm right there with you. This technology right now is just a transitionary type of idea, right? To get back into our own biotechnical, you know, our essence, who we are.
So sometimes I get chided for, you know, putting my head in the clouds by getting the secret space program people to come in to talk about the way much more advanced technologies that they've been using up there. And, you know, it's all very well, but we have to balance out, you know. So it's real. It's there, the secret space program. I mean, you talk about Pine Gap in Australia and the bases in Area 51, they're all there. And James is testimony, his work is testimony of the existence and the reality of all that. So why couldn't we just put both together and have somewhere in the middle, and we shall meet, and something will come out of that. And like James was saying over and over, that the secret space program had to shut down in a couple of years, and so I've been kept on asking. So then, where are the technologies going to be? Who's going to inherit them?
That's right. Then, that's a great question.
Yeah, and Elena was saying that, oh well, you know, it's going to go to the private healing clinics, and they're going to charge a bomb. No, I mean, again, we're talking about money. We want to heal the masses out there because this planet is in trouble. There's so many that needs help out there. So I don't know, it's something for us to think about. So it's good to bring two sides together, you know? Yeah, science.
Yeah, it's sounding like what they want to do is something similar to the Elysium movie.
Yeah, right.
Check that out.
Okay, I'm sorry, we've been talking too much. I'm not giving others a chance to ask questions and add to the equation. James, I interrupted you. Is that all you want to bring in here, or do you want to say some more before we go to another person?
No, that's good. Thank you. Thank you, Andrew.
Thank you, James.
Yeah, okay, so we go to Ron. Ron, do you have anything that you want to say before we close the meeting?
Nothing really, other than somebody mentioned Patrick Kelly, and he's got a new revision out that came out 2 days ago on the 5th. So,
oh, thanks for that. I did not know that. That's good.
That's a good reminder. Let's look at that. Yeah,
it's February 5th.
Thank you, Ron. Okay, so what about Richard? Richard, have you got anything that you want to add to the conversation? I have unmuted you now, Richard. Richard, you are unmuted. Richard? Okay, I guess we move on to until Richard's ready. Joe. Hi, Joe. Joe Martinez. You are unmuted, Joe. Do you want to say something before we close the meeting? Okay, let's go back to Richard. Richard, are you there? All right, then. I guess it is time now to adjourn this meeting to the next meeting, which will be on
Can I have one more?
Sorry?
What was that, Franz?
Can I have one more?
Oh, sure. Fred, go on then, Fred. Come on.
One of the things, this is more of a precautionary point to some of our fellow listeners out there. A lot of times when we start looking at 0-point energies or capacitor energies or some of these others, we start from the power side of the circuitry. And from what I've been working on, I think we were actually working backwards, and we should start with the ground or the discharge end and work our way back and start working, increasing small amounts of the potential differences to bleed off the circuit, so you have all the safety parts of your circuit in place before you tap into some of these large 0-point things. So when you're building your circuits, my warning is start from the end point and work your way back to your power source. Any comments on that,
That's a very
Andrew?
good point I should mention with that, because a lot of these devices, one of which is very interesting, over in Spokane, Jim Murray and Paul Babcock doing amazing work with their flyback transformers. The load is very important, the impedance matching of these systems. So when designing systems, most of the time, like with the Joule thief, like you were saying, or we were going back and forth and talking about shorted coils, there's a reason for having a shorted coil on there, because it actually creates a demand where this energy can be stored. And without creating the areas where the energy can be stored and shuffled, because you don't want to just create a dam, or the analogy is a reservoir, creating the proper load so that as these surges of these subtle energies build up, they have a place to be stored for a temporary period of time and then shuffled back and forth to flow. Without those dams, or these analogies to these reservoirs, the energy is not only able to, it can't build, as well as it can actually become detrimental, meaning that devices that have a COP greater than 1 can be detrimental if the feedback is not properly designed, meaning that if you're drawing more energy from the environment than you really should, it could actually cause detriment to biological structures, meaning that imagine instead of having neg entropy, if you did a system where you increased entropy several fold, that means that whatever is in biological systems aren't going to do too well around those type of systems. And that's a very important thing I've found in this work of when developing devices. If you do not feel safe, or if your health is being adversely affected being around a device, it's probably not a good idea to be operating that device, and an iteration needs to be changed. Just very important point of, even if you get a COP greater than 1, make sure that the device is biologically safe to be around, because some of these systems that can produce COP greater than 1 can be quite detrimental to biological structures. So, safety first.
Right. Thank you, Andrew.
Very important.
I was just thinking that since Anthony can make it as our second speaker today, I guess we will bring him forward to March the 7th, okay, which is same time, because that's good for him. That's his time zone on the 7th of March at 10 p.m. and possibly with another speaker yet to be confirmed, perhaps from this part of the world, okay. Anyway, right. So there being no other business, folks, unless Eliza, you have something else that you want to add to finish, to complete the meeting.
Oh, that's about it. So yeah.
Press, that's it, right? Okay. Okay. So there being no other business,
Yeah, go right ahead.
Sorry, Press, did you say something?
No, go right ahead. I'm sorry, we got a lag. Go ahead and wrap it up.
So there being no other business, this meeting, the 49th meeting, is now adjourned to the 50th FESIG meeting that will be on the 7th of March, same time, 7 p.m. PST, Pacific Standard Time. Thank you, everyone. Thank you, Andrew, for speaking here at FESIG's 49th meeting. Namaste. Thank you.
Thank you.